Today I will present my research. My name is Arya. But before I present my research, I will tell a story. This is the photos of my senior in high school. They already made research about SLR as ferry detector. But in their research, they already can show that the SLR can be used to detect ferry in water, but they still use the manual measurement. We measure the histogram, use a ruler. That we know ruler can be accurate enough to show the concentration. So I want to make more accurate and show the concentration of the ferry. I made my research about FED alpha software for detecting ferric ion in water by using Visual Basic. The background. There are so many water area in my country, in Indonesia, like river, lake, or sea. But there are so many too that already contaminated by chemical substance like ferry. During this day, when people want to know about or make a research about water pollutant, they must go to lab and doing with the people that already have experience in the lab process and spend a long time. I want to make this more easier. Just take the photos and transfer to the laptop that already installed my program to get the same result. From the background, the problem statement is, based on my house water pollutant problem, I want to measure ferry pollutant easier than lab process with FED alpha program. And the purpose of the research, to make the design of prototype of ferry ion detection in water using the Visual Basic programming language. The second one, to examine the potential of FED alpha program prototype-based programming language Visual Basic as the detection levels of ferry ion in water. The research methodology. The research methodology is experiment. The design is using randomized complete design with 6 treatments. Each treatments repeated 40 times. The concentration test consisting of, that's a mistake, 1 grams until 2 grams per 100 milliliters of water with the range 0.5 grams. And the procedure, the first one, we make the data control. The first step, we make the FD3 plus liquid, then take to the capture box and take the picture with SLR. After we have the picture, we input to the program. We input to transfer to the laptop that already installed the program. Then input the program. The program will read the image and then show the pixel value, frequency, and probability. After that, we make the range of data to make the control, and then make a coding, then input to the program. After we make, we have a data control, we make the experiment to know the validation of the program. It's same step, but in the last step, if the photos valid, they will show the concentration. If the photos are not valid, the concentration will not be shown. This is the table of data collect with 6 treatment. This is P0, G1. P0 means I take the picture without prism, and P1 it means I take the picture with prism. G1, G2 is the distance of from the lens to the liquid. This is the flowchart. The program starts from input the photos, and then the photo will read and show the histogram. The histogram will read, and then matching the pixel value with database. If the data didn't match, they will back to input photo. If yes, we'll match frequency with database. If no, back again to input photos. If yes, matching the probability with database. If no, back again to input photo. If yes, all of 3 data will calculate to show the concentration. And then the end. This is the coding to get the pixel value, frequency, and probability. And this is the coding of the data control. And this is the program interface. We load the picture, and then the program will convert to grayscale, and then we move to gray image histogram, and then we try to find the max pixel value with max frequency, and then get concentration, and then the concentration will be shown. And the conclusion, so my APCYS15 program can measure the ferric ion in the water easier than lab process. The second one, the working of the ferric ion in the water detection software begins by inserting images that have been invalidated and then open the histogram. After the histogram obtained, the levels of ferric based on the data will be obtained from the program APCYS15. Ferric levels detected was from mass 1 grams up to 2 grams. Is with a span 0.5 grams contained in 100 milliliters of water. And my future research is needs to detect the ferric more than 2 grams, find the formula to make the program more accurate with minimum rules, and the last one, try with another chemical subtest. So APCYS15 program will be measured fast, accurately, and efficiently. That's all. Thank you.
No need to use that.
Yeah, okay.
Because it's fine. Pass. Okay. From the photo based on DSLR only. And I see there is many rules of the DSLR.
Yes.
To take a photo. Okay. Why don't your future research work include using another camera? Not only DSLR.
It's means in the second point. I mean this. If we try to with another camera, we will get maybe million database, and from the many database, I will make the form. We will find the formula to get a new coding, and then maybe we'll input to the software, and we will not need again just maybe we can do with another camera. Will be my future research.
Can you tell us how do you calculate the concentration? How your program calculates the concentration of a sample water?
This is the my control data. If we input to the program, if pixel value for the 1 grams, if the pixel value between 204 and 208, and then the frequency between this and probability between this, it will be 1 grams. Same like 1.5 grams and 2 grams.
How do you got that value? How do you got that value?
From the data control.
The benchmark.
Yes, the from.
It's actually the standard benchmark.
Yes, I do the data control. I take
you
the.
made the benchmark.
Yeah,
I want to see the one that you make the benchmark. Not this one. The sources. This one. This is how you make the benchmark.
yes, this is
So,
so I make the Fe3 plus liquid with the pure ferric. Then I take the photos 40 times, and then I make the range for my coding.
meaning that in this, when you are doing the benchmark, you already know what is the value of value inside that water
Yes.
for the benchmark.
Yeah, we will know for 1 grams, it's the pixel value is from this to this, and then
How do you get that data? How do you get the pixel value? How do
Oh.
you get
the pixel value frequency.
Yes.
From this code, the program will look the pixel and then show the frequency, the pixel value, frequency, and probability. The pixel value it's only 256 because of I use grayscale, and the frequency if when the program loops, they will check where is the most type of colors that always appears in the photos. Pixel value is the type of the colors. So if we do with normal photos, it will have maybe 16 million pixel value. So it will be wait for my program. So I convert to grayscale to make more easier to check the program check and do the loops.
Okay. You have like pixel value, frequency, and probability. What does those mean in physical life? What is pixel value?
Pixel value is the type of the type of colors that grayscale has.
Type of colors means
Maybe, from white until the dark side.
okay.
It's pixel value. The frequency is the pixel value that how many times they appear
in the image?
yeah,
In the image.
the photo.
I see.
And the probability is this is the formula for probability. The frequency of the pixel.
Okay, so what is 200 something pixel means? You say it's type of color, right? So what color is that?
Grayscale. It's the
You only use grayscale.
like gradients from grayscale.
You only use grayscale.
Yes, yes.
Don't use RGB.
No.
No.
I like grayscale.
Because if we, like I said before, I try to use grayscale and my program will look so many times and it will my program will not responding.
That's normal.
And do you control the ambience?
Welcome to the computer science.
Yeah, because this is using Visual Basic that is very
And
old.
every time you take the picture of each sample, you control the same amount of light, same ambience.
Yes, with sorry, take the photos with the same light.
Yeah, let's say you have 2 samples. If I take the data for sample 1 in the afternoon and the second sample in the evening, will it be the same?
No, it will be the same because I made the capture box very dark.
I don't see it in your presentation.
Sorry.
You need to tell us.
And then I use the one LED lights from here. This is the liquid and this is my lens. So the box from the aluminium, and yes, I take the photo. So the sunlight will not.
Now we start to know what you're doing.
And only DSLR. We cannot use that type of
Yeah.
Yeah, because
camera.
because SLR I can control the manual like ISO or so.
Okay, last from me. Okay? Okay?
You still have 5 minutes.
Have you tested the accuracy of your program?
The accuracy I test with the data experiments to check. Sorry. With this, I made my 1 grams again, and then input again to the programs. I just have 3 image error.
If your sample water that you are trying to determine the concentration of air differ from the control data, how would your program handle that? If it's not 1 gram, not 2 grams,
It will not show because
it is
the database.
it can only detect an grayscale image, a grayscale image that only stores 1 gram of ferrum concentration,
No,
2 grams, only that.
When I take the photos, it still use RGB, but in the program, the program will convert to grayscale. If 1 gram until 2 grams, because I just try with 1 grams until 2 grams.
1 gram to 2 grams. How many samples? 1, 1.5.
1, 1.5, 2.
Only 3.
Only 3 samples.
Sample control data. If there's a concentration, if there's a sample with concentration 1.2,
1.2.
how would your program handle?
There there will be not valid, or maybe in the 1 grams.
So you trash it down.
Can I see the slide with the flow chart?
I'm sorry with the small one.
Okay, input photo. Like then you read the photo. Input photo and read photo is actually the same, right? And then
Just slice that.
histogram. So meaning that you ask whether it's histogram or not, because you have the division over there.
Sorry?
The diamond shows division.
Yeah.
It's done now.
So it will check.
Yes.
In the program, it will read whether it's histogram or not.
The histogram, if we see in the interface the histogram, if we just read the histogram, we cannot know the pixel frequency probability. The decision means it's the histogram show the details, to show the details about pixel frequency and probability.
The length of the histogram. Right?
Yeah.
The length.
Every
value wide.
Any questions from the audience?
No.
Questions? Okay, thank you very much.